A literal equation is an equation with several variables. A literal equation is an equation with several variables. And so what we're going to do with these is we're often going to solve for one of the variables. So what we're going to do is we're going to write this equation in terms of another variable, meaning that we will have one variable, x equals something, but it'll have that x equals will have y's and z's in it. Now, the thing is, we cannot have the variable that we're solving for in the answer. It has to be the variable we're solving for and everything else. We'll see examples of that. So solve for the indicated variable. K minus 2 over 5 equals 11j. Solving for k. So we're solving for k right here. So we need to get k by itself. So if we need to get k by itself right here, imagine that this j is just part of, it's just 11 maybe, and we'll solve for there. So the first thing we would do is multiply both sides by 5, and we'd have k minus 2 equals, let's see, 5 times 11, that's 55j. Then we're going to add 2 to both sides. So then we see that k equals 55j plus 2. And so we solved for one variable in terms of another. Now, we may have to use some other techniques and tricks from properties that we know using them in opposite. So if we have 6q minus 18 equals qr plus t, what we're going to want to do is we're going to want to get first all of the variable we're trying to solve for on one side. So if we're going to solve for q, I'm going to take minus qr over here. So I'll have negative 6q minus qr minus 18 equals t. I'm going to add 18 to both sides. So I'll have negative 6q minus qr equals t plus 18. Now, what you'll notice is that I am trying to figure out what I'm solving for q. I'm solving for q. And here I have negative 6q minus qr. Well, think about that. There's a q in both of these terms. So we're going to use the opposite of distribution, and we're going to write q times the group minus 6 minus r. Q times the group minus 6 minus r equals t plus 18. We see that if we distributed q to negative 6 and negative r, we would get the same thing as this, negative 6q minus qr. We have to think tricky things like that. Yeah, who would have thunk that we would use the distribution property not in the way that we normally distribute? We still distributed, or we almost undistributed if you want to think. So we have q times the group, negative 6, that's a negative 6 in here, minus r, equals t plus 18. Now we're still trying to solve for q, so if we have q times this group, we undo multiplication by dividing this by negative 6 minus r, and we have q then equals t plus 18 over negative 6 minus r. Now, we can often use, and solving literal equations are most frequently used when it comes to simplifying formulas. So if we have the volume of a rectangular prism, the volume equals the length times the width times the height. If we were trying to solve for the width, if we wanted to solve for w, we could take v equals LWH. If we divided both sides by LH, we would see then that the width equals the volume divided by the length times the height. And there we have solved for LH. Odds are for you that this undistributing thing is still confusing, so go back if you need to and rewatch this distribution property take place. We'll be sure to review it in class. Now, for the other half of this section, dimensional analysis. Dimensional analysis, what is that? Dimensional analysis is essentially carrying out unit conversions. So essentially converging from one measurement to another. So if we look, a 10K run is 10 kilometers. If 1 meter equals 1.094 yards, find the length of the race in miles. Find the length of the race in miles. So what we're going to do is we're going to start off by saying that we have 10 kilometers and we want to get to miles, but first we have this conversion of meters right here. So we're going to take 10 kilometers, and the way that we have to set this up is we have to think that, you know how in multiplying fractions you can reduce diagonally like that? We're going to do that reduction but with our units. So if we think about it, 1 kilometer is equal to 1,000 meters. We have to make sure that we see that this kilometer and this kilometer will reduce with each other, and then we use our conversion factor. This is called the conversion factor with here. Let's see, so we're in meters. We know that 1 meter is 1.094 yards, and we know that 1 mile is 1,760 yards because it gives us that right there. Now let's see, if we think about it, kilometers here is going to reduce, meters is going to reduce, yards is going to reduce, we'll be left with miles. We'll be left with miles, which is the conversion that we want. So now we multiply straight across. So we take 10 times 1,000 times 1.094, and we get 10,940, and we divide that by 1 times 1 times 1760, so divided by 1760, and we see that we get about 6.2, we'll round that to 3 miles. So a 10K run is about 6.23 miles. So that we did it with one unit. Now let's look at it with another. A car travels 100 feet in 2.8 seconds. Find the speed in miles per hour. So let's see, if we go 100 feet in 2.8 seconds. Now we have to convert both feet to miles and seconds to hour. Let's start with the feet maybe. So we know that in 1 mile there are 5,280 feet. We know that our feet will reduce, leaving us with miles. Good. So now the seconds. We know that, let's see, if you don't know how many seconds there are in an hour, that's fine. I forget sometimes. So let's see, seconds. We know there are 60 seconds in 1 minute. And we know that there are 60 minutes in 1 hour. So now our seconds will reduce, our minutes will reduce, we'll be left with miles over hour. Now we multiply straight across, so we can do, let's see, 100 times 60 times 60, 100, times 60 times 60, and that is 360,000 over 2.8 times 5,280, which gives us 14,784. This is in miles and that's in hours. So then we divide, we take 360,000 divided by 14784, and we are left with, the car is going 24.35 miles per hour. And that is dimensional analysis. We are converting units through conversion factors and careful about where your units happen to end up with a final result. For our homework today, we are looking at page 371, 8 through 15, and 24 through 27. If you look at number 8, it says that U equals VW plus Z, and it asks us to solve for V. So we're solving U equals VW plus Z. Let's rewrite this so it's a little neater. U equals VW plus Z, solving for V. So let's see, first thing we'll need to do is subtract this Z out of the way. So we'll have U minus Z equals VW. We're still looking to get this V by itself, maybe divide both sides by W. So then we see that Z equals U minus, sorry, not Z, V equals U minus Z over W. And we have effectively solved for V. Have fun.